the main event is the Ariane Ultimate that wants to send an SSTO to orbit. And we will discuss also the Transporter 2 mission and the NASA program to refuel satellites in orbit. Let me switch something real quick. Okay. So, about Roscosmos, I'll switch to, excuse me, about Roscosmos. There was a risk with the Progress spacecraft on July 1st. There were 2 debris identified by Roscosmos that could hit the Progress spacecraft. The encounter could have been 1,500 meters or 500 meters respectively for the 2 debris. The 2 debris were the rod. The smaller one was the rod that is used to keep the Starlink satellites together on the second stage of the Falcon 9, and the other one was a dead Starlink satellite, number 1691. And some people said Roscosmos could have anticipated the trajectories and not launched the Progress to avoid the collision, but that's not that easy because on the low orbit, the Earth's atmosphere can interfere greatly with the debris or the satellite, and if there is a sun flare, the atmosphere expands and the debris slow down, which reduces the apogee, which means the rotation speed is faster and the time of the encounter changes up to the very last moment. So this is extremely difficult for agencies to plan in advance the collisions and try to avoid them. So of course everything went fine because the Progress docked with the ISS, but there was a close call, and SpaceX is doing fine with mitigating the debris problem. They are deorbiting the second stage of the Falcon 9, and the fairings are, of course, dropping by towards the ground really fast. There are not so many debris with every flight, but because they launch so many Starlink and regular missions, even one debris per mission is polluting the low Earth orbit, and surely there is something they can do, because for the rod that is used to tighten the 60 Starlink satellites, they could easily attach it with some kind of leash to the second stage, and the problem will be solved. As for the dead Starlink satellite, there's nothing really they can do, but the problem is not that strong, because when a Starlink satellite does not respond to commands, because it has a huge solar panel which generates a lot of drag in the atmosphere, even when it's still high, and it deorbits really fast. So if you launch a satellite, there's nothing you can do when it dies, of course. So if we move to the second point, here is the official statement by Roscosmos, the agency. Of course, they are advocating for the problem. They're saying it was huge problem, but I don't think they even changed the orbit of the Progress. At least I didn't hear anything about it. So the much more interesting is a European Aerospike motor. If you don't know what this is, look at the bottom of the rocket here. An Aerospike motor is a different kind from the usual type. Of course, it's designed for the liquid engines, liquid propellant engines, and usually you have a nozzle that expands, and the Aerospike gets rid of the nozzle, and instead of this weird cone-like structure in the middle. What is really interesting with the Aerospikes is that they are efficient at ground level and in vacuum, almost the same efficiency, whereas a regular nozzle is either optimized for ground level with a short nozzle or for the vacuum with a very long nozzle. And since the first stage starts at ground level and ends in space, basically, the nozzle is only optimized for just a single point in the trajectory, and an aerospike could be really interesting for that matter. The Aerospikes are not the Aerospikes motor were researched in the 60s, but they were not used on any real rocket because there is a real problem with them. They tend to heat up a lot because there is a structure right in the middle of the flow that it's taking all of the exhaust flow, and it's really combined with the annular the annular exhaust. This kind of motors tend to heat a lot, and that has been the real struggle for making a working Aerospike engine. So this startup, in fact, two Spanish startups, Panji Aerospace and Aenium, are using a material developed by NASA that is really heat resistant and heat resistant. It conducts heat very well and is really strong against forces. The forces a motor, of course, is thrusting a lot, and your parts have to be resistant. The motor is 3D printed with only two parts. I have a picture here. So on the left is a 3D model. On the right, this is the internal part, the two parts. And the two parts are assembled with a lot of bolts and so on. So with only two parts, this is really efficient, easy to make, easy to reuse. They say it will be reusable 10 times. It will be used with a methalox, liquid methane and liquid oxygen propellant. And we will be able to deep throttle. The throttle is really interesting only if you want to make a lander, because when the rocket goes up, it's mostly 100% throttle. Only at max Q, the rocket usually throttles back a little. But you don't need deep throttle if you don't want to land the first stage motor. Of course, this is the whole rocket is only at the first draft. There is no timeline for commercialization, and I don't know if we will ever see that again. I mean, in real life, I don't think it's that advanced that we will see it for real sometime. But the MESO rocket, as it's called, is supposed to put 150 kilograms to low Earth orbit, and excuse me, 150 kilograms to low Earth orbit, and probably will land propulsively. So that there is that. I don't know anything else about it. If you know something, don't hesitate and tell me. So next one, we have ESA that wants to launch astronauts on its own. At the moment, the ESA astronauts are flying with either the US with Crew Dragon or the Russians with Soyuz. And they want to, the ESA wants to have the ability to launch astronauts on its own. So I'm saying ESA, but it's mostly the French agency that wants to have this capability, and they have to advocate that or towards mostly the Germans. So Europe has the knowledge. They made the ATV, the Orion service module, that's the important part for using a spacecraft in orbit. And also they excuse me, they made one module on the ISS and two that flew with the space shuttle. And the important part would be the re-entry. And the re-entry, they are actually working on a project, the Space Rider, which is some kind of X-37B, but smaller, which is a lifting body for small payloads. The lifting body is sent as a satellite. It has its own payload inside, which when the payload is exposed to the vacuum, it's for the purpose is to test new materials or new techniques, and but at the end of the test, the Space Rider or the X-37B closes the doors and comes back gliding towards the ground. The X-37 is a kind of a small space shuttle, but the Space Rider is just a lifting body with no wings. For the re-entry is perfect, but to land it would be a bit too fast. So they have a parafoil wing that deploys just before landing. That's really interesting. So this could be the system used to launch people. Actually, the payload bay on the Space Rider, this is an Italian project launched on the Vega launcher, which is also an Italian launcher. It has the payload bay is large enough to put to provide the same space than a a Mercury capsule. So at least on paper we could launch one person into orbit. But of course that would cost a lot to the ESA. So they are looking also into cooperation with the US. And in the US, the company SNC, Sierra Nevada Corporation, has a Dream Chaser. They are launching it as a cargo version towards the ISS really soon, in a few years. But they really want to make a crewed version. They competed against SpaceX and Boeing to launch it, but unfortunately for them, they lost. And they could be interested in a partnership with ESA to provide the Dream Chaser. The Dream Chaser will be launched by ULA, but it could be fitted into an Ariane 6 fairing with no problem. There is also the Indian Space Agency with the Gaganyaan program, but it's historically there is no real cooperation between India and ESA, so probably not this time too. But the real thing would be Russia, which launches Soyuz rockets from Kourou, the spaceport of Europe, in French Guiana. They already send Soyuz with only payload satellites, mostly the OneWeb satellites, but they want to launch a Soyuz spacecraft from Kourou to reach the Chinese space station, the Tiangong space station. The Chinese made a point in sending their space station on an orbit that cannot be reached when you launch from Baikonur or any other spaceport, Russian spaceport, excuse me. But so Russia works with ESA already to launch Russian cosmonauts towards the Tiangong space station from Kourou, because they are already launching Soyuz. Most of the infrastructure is already there. So this could happen really fast. This could be a thing in a few years if the Russians cooperated with ESA, but I don't know what it would be. Probably between. I don't think the Germans will want to embark with ESA. Historically, the Germans didn't like the human space flight. At least they don't like having to build a rocket for that purpose. So it will be tough to negotiate, but I don't know. Maybe we will see that. So going on, we have Ariane Ultimate, which is at this point it's a plan, excuse me, from the CNES, the French Space Agency. At the moment, there is Ariane 5 launching or will launch soon because they have a fairing problem that is about to be solved. And hopefully this will be solved before the launch of the James Webb Space Telescope. But after that, in 2022, so next year, Ariane 6 will be the new launcher for Europe, but it's already obsolete because SpaceX changed the landscape completely with reusability with Falcon 9. And probably in 2022, we will see the first flights of Starship. I mean, the first commercial flight, or at least the first really useful flight. So Ariane 6 will most likely only launch a few times a year and not be really interesting on the market. But improvements are already planned on Ariane 6 up to 2030, 2035. So if you want to make another launcher, you have to plan ahead. And the CNES wants to plan ahead for 2040 at the end of Ariane 6's life. And they have planned something very bold indeed. They want to use carbon nanotubes to make a lighter, stronger structure, and use really a lot of 3D printing to make it lighter and easier for maintenance, because you have less, with 3D printing you have less parts, it's much easier to manufacture, so it is more easier to for maintenance, because they want to reuse the launcher. And of course, I told you that in the introduction, they want to make an SSTO, which is a single stage through orbit. And to do that, they need something light, but also something really performant with energy-dense propellant. What does it mean? Usually, the rockets are using propellants that are derived from petrol. This is RP1, which is refined kerosene, or cryogenics, which is liquid oxygen with liquid methane or liquid hydrogen. But they want to use a synthetic propellant with a lot of nitrogen atoms stacked inside it, which would make it really energy dense. Energy dense would mean with a cubic meter or foot, whatever, a unit of volume, you have more energy, which would mean a smaller tank. And of course, a smaller tank means a lighter structure. And this propellant they are working on is also a monopropellant. You don't need usually you need a fuel and oxidizer, RP1 plus liquid oxygen, or liquid methane and liquid oxygen, and so on. But with this propellant, this would be a monopropellant on its own with a proper engine ignition. It would ignite without any oxidizer, which is really interesting because it is much simpler. There's only one tank. The structure is simpler also. Only one pipe, only one turbo pump, and this propellant is also storable at room temperature, which is really useful to simplify the ground operations. And we have a really nice picture of what could happen, or most likely would not happen, I think, but who knows. This would be a single stage to orbit, not like the Starship or the Falcon 9, only one stage and the payload on top and the motor at the bottom. It will reach orbit on its own. SSTOs have not been made up today. There have been attempts with the replacement for the space shuttle. It could have been an SSTO, but the technology wasn't up to it, so it was cancelled. And the Atlas 1, the first Atlas launcher which launched John Glenn into orbit, was almost an SSTO because there was no staging per se, but it dropped two additional motors that were used to lift off. Of course, it did not come back and land propulsively. The Ariane Ultimate, this is a working title, of course, is designed to reach orbit with only one stage, drop its payload, and then come back a little bit like a Starship or Falcon 9 first stage and land on the launch pad. And of course, they want to make it work as a Starship and have frequent flights only to low Earth orbit, because if the market is only for low Earth orbit at the moment. And to reach higher orbits, they would use a space tug, which would be some kind of small motor that would, with a propellant tank, that would stay in orbit and never come back, would be refilled by the Ariane Ultimate spacecraft, and would take the payload, the geostationary payload satellite, would take it, grab it, and push it to the target orbit, or maybe towards the moon or Mars, I don't know. The CNES, the French agency, says there's no major blocking point towards this technology, which is a good thing, but you have to take it with a little grain of salt, because of course they plan for 2040, so the technology isn't working yet. They have just proved that it could in theory work. The physics is working on paper, but they have to draw financement, to draw money to start the actual work. So what do we have now? We have SpaceX, some SpaceX news. I will be a bit quicker on that because you can have all the news you want from any other sources that are much more up to date than me. So there was the launch of Transporter 2 on June 30th. I think I'm doing that wrong. So there was a delay before launch, and Elon Musk went on a rant on Twitter about he said the range, the safety range was too big because he thinks rocket flights have to become mundane thing, and a mundane launch would mean no need for a gigantic launch perimeter, security perimeter, and he's advocating for his own firm. He has some problems with Starship development. The administrations wants to do more security checks. So by ranting like that, he puts pressure on the FAA that has to deliver the permits for every launch. So the rideshare program, it works really well. This is a program by SpaceX to launch a lot of really small satellites, nano satellites, and some micro satellites. This is the second flight in 6 months, the second flight in this program that launched 88 satellites, including a few, I think, four starting satellites. And what is interesting visually is that there was a RTLM return to launch RTLS return to launch site mission. We'll show you that. I think it's here. We have the launch here, and this is really interesting. Should have planned this better. The first stage is coming back, and we had a really interesting view during the descent. I'm accelerating a little bit. Here we are. So it's landing back to the launch, near the launch pad, and we see the Mach effect on the grid fins, which is really nice to see. And of course, the boost, there is a really nice view because the cameras, the 4K cameras on the live stream were much better than what we can have in the middle of the ocean, of course. So this is the booster landing. And what is interesting with a landing to the ground is that the turnaround to refurbish the booster is really shorter, which is interesting for SpaceX because it means less work on the booster, and this is money gained easily. So despite having launched 88 satellites, I'll try to show you those satellites. Despite having deployed 88 satellites, they managed to have the booster come back to the. I'm sorry, I don't. This isn't working. So they managed to get the booster back. This was really interesting. So the problem with there are pros and cons with this rideshare program. The pros, of course, is the price. They are 5 times cheaper than any other competitors. The competitors are the small rocket launchers. There is Rocket Lab. There is Virgin Orbit, of course, that launched the second satellite really recently, and others to come. But SpaceX is 5 times cheaper than those, so they can't compete with that. Of course, there are also drawbacks. The drawbacks is that it's really hard to launch a small constellation because a small constellation needs a lot of launches. If you launch 4 satellites into orbit, you don't want them. Maybe they are observation satellites. They want to take pictures of the ground, and if you launch 4, you want them to be equal. You want to have a satellite anywhere from any point on the ground easily, so you don't want them to be packed and really close to each other. So on one launch, it's really hard to do that. You could do that, but you have to use fuel on your satellite, and this cost, and in turn, this is money you have to spend on that. So ideally, you want to launch a small constellation with one launch per satellite, and you cannot do, if you do that with a wide-share program, with one launch every 6 months with 4 satellites, this is 2 years time, and this is too long for many customers. And of course, if you launch, you want to choose your orbit, and if you are one of 88 satellites, you have not really much to say about the target orbit, and this might be problematic for you. You will have to wait for the good opportunity, and this means delays, and delays means cost. So although the ride-share program is really interesting price-wise, the other launcher are sure to still have clients, a lot of clients. And we have the Starship news. I will be fast on that because this is going really fast, and you can have all the news you want. Mostly, I advise you to go to NASA space flight. They do a really good job, and you should watch their videos. They publish videos. They have live feeds. They have a lot of things. So, but I noticed something interesting. The BN3 booster is ready. The BN2 will be scrapped. So the booster is the first stage, the super heavy first stage that will launch the Starship into high altitude and come back to land. And there was a debate between whereas the BN2 or BN3 or BN3 would be the one that launched SN20 for the orbital test flight, and it will be BN3 because BN2 will be scrapped, said Elon Musk. So there will be the BN3 is ready. It's already on the launch pad. It's not the actual launch pad. It's a testing launch pad. And the static fire will occur on the launch stand, the orbital launch stand, the one with concrete pillars, and the launch tower that is being built on the side. And that will be epic because there are lots of motors on that booster. And there are a core of Raptor engines in the middle that will be steerable, that will help gimbal and turn the super heavy to follow the right trajectory and to land propulsively. In fact, in the same way the Falcon 9 is doing, but there will be an outer ring of motors with no gimbaling ability that will have a slightly higher thrust and will be lighter because of they removed the gimbaling device, the pistons, and this is interesting because we have 3 types of Raptors on site right now. We have these outer ring Raptors with no gimbal power and with higher thrust. We have the center Raptors that are the D1 used on every test so far. And we have the vacuum engines. The first one arrived recently with a very large nozzle. This is basically the same as the other ones, really close to, but no gimbal ability and a really large nozzle. They will be mounted on the Starship on the outer ring. The 3 on the middle would be sea-level Raptors, and the 3 on the outer ring would be the vacuum engines. The 3 in the middle will be used. When the Starship will detach from the booster, all 6 will be ignited, and then the sea level will be shut down quite quickly because they are less efficient. and the end of the orbit burn will be made with the vacuum Raptors. And when landing, only the sea level Raptors will be used, of course, because there's no need for high thrust, and the vacuum optimized Raptors will not work on sea level. So there's still the deadline for the orbital flight. Elon Musk and Gwynne Shotwell both said the goal was mid or end July, but Musk said also this is mostly an internal goal, and he said if everything is doing extremely well, they could do that by the end of the month, but it is most likely that not everything will go well, because this is still a work in progress, and I don't know when the launch will happen. I'm betting mid-September, if everything is doing fine, if there's no major setback. I think we can expect a launch mid-September, maybe later, but I'm really confident the launch will occur before the end of the year. So moving on, we also have some news from NASA that has granted $370 million for advanced technology to 14 companies in total. There are 3 major companies that share the most part of that money. This is about on-orbit refueling technologies. So we have Lockheed Martin, which will test a transfer of liquid hydrogen between 2 spacecraft, or most likely 1 spacecraft and simulated interface. The problem with liquid hydrogen is it's really cold, minus 253 Celsius, almost 0 Kelvin, and the technology is really hard to handle, to master, to transfer this liquid hydrogen. So they will test many different technologies to transfer a short volume of hydrogen. This will mostly be a demonstrator to know what works in 0G and what doesn't. And ULA on this will have a lot of money to demonstrate the smart propulsion system on the sort of Centaur 5. The Centaur 5 is a second stage of the Vulcan rocket, and it is supposed to have a lot of milestones to reach. And the first launch, it will be just a regular second stage, but it will, in the long term, it will handle the storage of the cryogenic propellants, which is liquid oxygen and liquid hydrogen, for a very long time. We are talking months, and in future versions, probably years in orbit, and the ability to relight the engine multiple times. So they will have money from NASA to demonstrate the Centaur 5 upper stage can indeed reach those milestones. And I think this will be really interesting, because such an efficient upper stage would be really interesting to launch payloads towards the moon. If we could refill in orbit this second stage, it would be extremely efficient, really not like the Starship. Starship is made to be cheap, but not really efficient energy-wise. But the ULA option is to have a second stage really efficient, really that way. The interesting part is that because it's efficient, it doesn't need a lot of propellant. You have to refill it in orbit, but not by much. Excuse me. So just one launch to refill it would be enough to send a payload toward the moon. And on the moon, you can have in situ resource production. and they really hope to produce liquid oxygen and liquid hydrogen on the moon, on the surface of the moon. This is a long-term goal, of course, not in the coming months. And if they can achieve that, having a petrol station basically on the surface of the moon, they could refill their Center 5 upper stage, which could then go from Earth to the moon really easily and cheaply, much cheaper. This would be much cheaper than the Starship. But since it at least a decade in the future, I'm sure SpaceX will come up with something to counter that. And of course, the third one is SpaceX, whose goal is to transfer 10 metric tons of liquid oxygen from a spacecraft to another, and this would be Starship to Starship. If they achieve this goal, they will be awarded a few $1 million for that achievement. But we also have some smaller contestants. We have Rocket Lab, which will soon launch the Capstone mission, which will demonstrate the stability of the orbit for the Lunar Gateway Station. The orbit is really strange if you look at it, because this is an elliptical orbit around the moon, but always facing the Earth. It's turning with the moon around the Earth because of the gravity. The gravity forces are pulling the orbit from day to day, and it's going from it's basically turning around the moon. So they will try to prove that it is possible. And this is really interesting because the Rocket Lab has a really small rocket. The Electron rocket is as big as a landing leg on a Falcon 9, basically, and they will send a payload towards the moon. We also have Masten Aerospike that will demonstrate a precision landing on the moon with hazard avoidance. Basically, what the Chinese are doing with their landers, they have landed a spacecraft with a rover on the far side of the moon without any direct connection toward the ground, and this is the same thing Masten Space will try to demonstrate. And an interesting lander also by Intuitive Machines, the Lunar Hopper, which will basically land on the ground like an usual lander, but then will move from one place to another by doing small hops. How you say that? Small hops. It will jump from one place to another, basically. This is really interesting for places that are hard to reach with regular vehicles, such as a rover or thing like that. A small crater with or even a big crater. This would be dangerous for astronauts to explore. So this lander that hops from one place to another will be really useful. And we also have Nokia. Nokia will have money from NASA to demonstrate how a working 4G network in space, probably around Earth, but I think the goal is to deploy that around the moon. And SNC, Sierra Nevada Corporation, of course, will try to produce oxygen from a lunar surface, but not the way I was talking about before. This is with solar power and adding methane to the mix. The goal is to provide oxygen for the astronauts that will work on the moon. So, yes, I had a Center 5 illustration. So this is it for today. If you have any questions, don't hesitate. I can see you chat. If you don't hesitate to ask me. You can ask me now, or if you're watching that later, you can ask me anytime on Twitter or Facebook. I have this is Getting to Space at the on any platform. So this will be it for tonight. Thank you very much for staying with me up to now. This is Getting to Space, signing off.